been thinking about how trumpets get the even and odd harmonics. I've been thinking that the explanation they have in the texts and AI and Google are all wrong, and you'll notice what it says. The shape of the trumpet is designed so that the second and all higher resonances have risen, so the frequencies and ratios 2, 3, 4, etc. In other words, they get the complete harmonic series, and the way they do that is through the shape of a mouthpiece, is a trombone mouthpiece, and a conical flare of the bell. And I think that's incorrect. I think something about the way you buzz the trumpet creates more of an open whole harmonic. So it's easy to test. You just get some tube. This is perfectly even tube. I'm not going to use a mouthpiece at all. And I'm going to make some notes. So what I'm going to do is I'm just going to blow into this for a single note, and according to all the Google papers, let's look it up. Why does the trumpet have both even and odd harmonics? And they all look at the same things. They say it's the mouthpiece, the bell, blah, blah, blah. A clarinet's mostly odds. And it is a closed tube. This is just a tube. There's no flaring, there's no conical, there's no mouthpiece. And I'm going to play it, and then I'm going to look on the spectrograph, and if we don't see a peak at 1 and 3, then their theory is wrong. What's the right theory? Who knows? But let's find out. I'm going to play this, and then I'll hit record, and we can see what it looks like. Now let's look at the waveform. And here you can see the fundamental. Here's an even harmonic, and here's an odd harmonic. And it's quite easy to see that the even harmonic is above the odd harmonic. And in the clarinet, this one will be a little bit right about here. So odd, even, odd. The theory's wrong. So you can see the explanation, it's wrong. A simple closed cylinder only creates odd harmonics, which is true. Trump is mostly cylindrical, which would normally block even harmonics. They blame the mouthpiece effect and the bell effect, and it's both wrong. I just demonstrated it. And if you listen to a normal trumpet, hear them side by side, the plain tube will just be dull and lifeless. But you'll hear it has the same kind of qualities as a normal trumpet. So what's going on? Is the embouchure? Is it actually not a closed hole instrument? Is there something mysterious going on? I mean, that tube doesn't sound like an odd frequencies. Like you can hear the brittleness of the clarinet in odd frequency instruments. It has the pure sine wave of a flute has all those even harmonics. But the trumpet with just a tube and a regular trumpet, despite the trumpet sounding way better than the tube, you can hear the quality of the sound. And you can look on the frequency analyzer and notice it has the even frequencies. It's a mystery. All right, decided to make one last comparison just so you can see how close these two frequencies are. And you can see for the trumpet that the first harmonic is actually stronger than the bottom one, but for the tube, the bottom is stronger. And thereafter, they are quite similar, though the trumpet, I wasn't playing it that clean, so you got a little garbage there in the around 1500, but normally I play that a little bit better. You can see they look the same. This warrants further investigation.